We all know that over the last several years, we have a major change and evolution of the storage, hardware in general, but storage specifically. With the NAND-based flash devices, we now have a single device delivering 1 million IOs per second, which until a few years ago, you could hardly get that performance from a huge disk array, right? So not only that, but now we have new storage technologies emerging, and we all have heard about the 3D Crosspoint from Micron and Intel. We have actually evolution in the networking space, with 10 gig becoming more or less commodity. The industry now is already kind of thinking about 40 or even 100 gig networks. And we all know that roughly every 2 years, the density of a service is growing. So what are all these things mean? That we see now a revolution actually with storage. We see the big iron disk arrays of the past dying off gradually, as being described in that Wikibon graph, and been replaced by software-based storage platforms that run on commodity hardware. No big ASICs at most parts, no specialized hardware, commodity. So this is the revolution that is happening in the industry. Essentially, what I call it, this is we democratize storage, right? Thanks to these new technology evolutions. Within these software-based kind of architectures, we believe at VMware that the hyper-converged model is one that has a lot of potential. We see a lot of traction and demand from customers out there. And we have a very large sample of customers to be able to develop this opinion and believe this is the future. Hyper-converged. And it is within that context that we started Virtual SAN, the design, which goes back to 2010, actually, when I first started that team here at VMware. And this is the context within which we are evolving the architecture. So Virtual SAN is the cornerstone of VMware's hyper-converged strategy. And not only because of the storage features, but also because of the management paradigm we are introducing through Virtual SAN. And this is actually, the management is one big theme they're going to hear about today. In fact, the demos later on by Rollinson are going to focus mostly on that. So I know most of you already know quite a bit about Virtual SAN. Let me do a quick overview, give me a few minutes to do that. First of all, for the audiences that are listening live, as well as for setting the context for some of the more detailed conversations later on. So what is Virtual SAN? It is a software-defined storage platform. It has a distributed architecture that has no single point of failure, no performance bottlenecks. It runs on every ESXi host in a cluster, the same host where your virtual machines run. It aggregates the local storage devices, both flash and magnetic disks, make them all appear as one big pool of storage, and which is consumed by virtual machines by means of policies. Virtual SAN also introduces a new paradigm of integrating with the rest of your infrastructure. Not only strong integration with hypervisor as far as the data path and the clustering features are concerned, but also management integration, so that you can manage your entire infrastructure, compute, storage, networking, from one pane of glass, whether that is a UI or APIs or DevOps tools. Okay? And we'll talk more about those. So at a very high level, vSAN's architecture is a tier architecture. The persistence layer consists of two tiers. One is a caching tier, which is flash, and the other one is, depending on whether we are talking about hybrid or all flash configurations, can be respectively magnetic disks or SSDs. So now we use those tiers differently in each of those configurations. In the hybrid case, the caching tier is used to get the majority of the performance out of your hardware. It is used, flash devices are used both for read caching as well as for write-back buffering. The write-back buffering here is actually quite interesting. We use it so that we turn a typically random aggregate workload that gets to your storage into a workload that is really benign for the magnetic disk. sequential or near sequential. We call it proximal. So that is what we strive to do in hybrid configurations with the right buffer. In all-flash configurations, it's a completely different story. What we do today is we try to, we do write-back caching in the first tier so as to allow for the user to have low endurance and therefore cheap SSDs for the capacity tier. So we use small, high endurance and therefore more expensive flash devices like NVMe devices for this write-back cache. And those guys absorb the majority of the write load that comes from the workloads. Hot data, in terms of writes, may stay there for a long time, perhaps even forever in that caching tier. And only cold blocks trickle back to the capacity tier. So the rates that the devices in the capacity tier, the SSDs in the capacity tier see, is only a fraction of the rate of writes that the first tier sees. Because thanks to this two-tier architecture, with today's devices and pricing, we get very compelling cost, even before space efficiency features that we'll talk about later today. Question?
On your performance numbers, it just, you're talking about a software product, and then you're saying 40,000 IOPS per host. I know you said it's got some flash and some disk, but like what flash, what disk,
Yeah, this is actually numbers. Good question. This is numbers actually we present last year. In fact, we'll come back to the performance. This is actually with pretty modest configurations. Some of the people here that saw this came to this the Storesfield day here last March, saw some of the actual details behind these numbers. This case was, I think, we had 2 to 3 disk groups in each host, with the caching tier being Intel S3700 SSDs, and the backend being 10K SAS drives. But don't stick with the numbers here. This is our generic slide from our product marketing team. This is not what I want to focus here. Just keep in mind that with the all-flash configurations, you can get clearly much higher performance, but even more importantly, you can get dependable performance, both in terms of IOPS and latency, even if your working set is not very is large or changes over time. Because the challenge with any hybrid configuration, not in vSAN, but in the industry in general, is that you have to size your system correctly. The amount of cache you create is appropriate for your working set. So you need to know what you're doing, right? And if your working set goes beyond your cache, then you start seeing performance dropping really rapidly. So that is the fundamental point I want you to take away. In fact, those numbers do not really mean much other than a very high-level guidance, because you can get bigger numbers for either case, or I can create also a workload that will bring your hardware on its knees, right?
So you're telling us that you are maintaining the multi-tier mechanism also for all flash.
Yes.
Does it mean that you can also use consumer-grade MLC drives and as a second tier, so very, very cheap drives?
So
you are not
today we support. That's a good question. I'll talk to you in terms of endurance characteristics. Fair enough. So today we support in our HCL drives that have an endurance as low as 0.3 device writes per day.
Okay.
Right. That's specific enough. Yeah. So yes, and those are quite cheap, and the prices go really rapidly down. Now, I cannot disclose information because those are under a special NDA with our partners, but we anticipate that later in this year, we're going to see some really beefy devices shipped by most main vendors with bigger capacities in the 8 to 16 terabytes, with very substantial downward pressure in the capacity cost. So yeah, and to be honest, I'll give you guys here a hint. I've never said this in public, but I'll stress this, that
you're about to.
you are having a first here. Down the road, this two-tier architecture for all flash may change. That's why I stressed before. This two-tier architecture makes sense for the economics we have today in the market, because those high-endurance devices are quite expensive. But down the road, if you have a device that is 16 or 32 terabytes, who cares what is its endurance? Because I can write a hell of a lot of data, even with an endurance of one device write per day, right? So we may do something different down the road.
Yeah. Enrico, the one thing I would say about a consumer SSD is I wouldn't use SSDs that didn't have power fail protection.
Yeah.
Yeah. So that it might be the low-grade flash, but it's still an enterprise SSD because it's got that capacitor.
And also, yeah, good point. Also, because we tested in the lab many hundreds of devices, some consumer-grade SSDs seem to have very unpredictable performance, mostly because of the software. You see the garbage collection kicks in and the whole device, falls on, down. So you have to be careful about those things. That's why we have an HCL.
We've got a quite specific question from the Twitters,
Okay.
which is how will vSAN work with Photon controller, which doesn't use vCenter? So is there an intention for that to be available in the future?
It will be available. In fact, I blogged about that a few weeks ago. So we are currently, this is a good, perhaps I can talk briefly about this. Virtual SAN has a management stack that is very well integrated with vSphere, but it is not part of vSender. It's a completely decoupled, independent software stack. Today, it ships with Cloud VM, with vSender, very well integrated. You don't need to install anything, click anything, it comes in the box, so to speak. Down the road, that software stack will work independently on top of Photon as well, without necessarily having to have vSender in the picture. Now, I can tell you, vSender is a great solution. Hundreds of thousands of customers use it. Down the road, you're going to see some impressive scale and availability features shipping. But there are many use cases where it is not in the picture, and we're going to be there. Yes, not that far in the future. Okay? So,
in terms of the mediums that are available, can you say anything about Crosspoint at this stage, and will you be sort of supporting it from launch?
So what was that about?
In terms
Crosspoint,
of, in terms of Crosspoint, can you say anything about that at this stage? And can you say when the product is launched, will you be ready to support it from day one?
Yeah, that's an interesting question. I'm afraid I can hardly answer that myself because I don't even know exactly the different form factors and when will be available. I can tell you that the NVMe form factor will be supporting it from day one. When down the road, as I understand from Micron and Intel, they're going to have at some point a DIMM form factor of this technology. VMware is already working very actively on that. Now, the exact dates I cannot really specify because I don't even know what are the timelines from all the companies involved. But we are working on that, so I expect us to be among the first vendors to support it. Okay, fair enough. Shall I move on?
Yes.
All right. So let's talk a little bit about the user in this overview. From day one, when we started designing Virtual SAN, our target was to go and build a storage product that targets the vSphere administrator, our customers. I mean, of course, we're happy for storage guys to use it, but really our target.
You know us better than that.
Sorry?
You know us better than that.
Yes. Well, I'm a storage guy myself, so. But really our target customer, right? Because certain design decisions, our target customer has been the vSphere guy. So because of that, we make certain decisions. For example, we made Virtual SAN an attribute of vSphere cluster. There is no an architectural requirement for that, but this is really convenient in terms of management. Essentially, now you take the existing abstractions, management workflows, APIs, tools that the customers know and use, and you just extend them to deal with storage. That has also a number of other advantages. So you don't have to create a storage cluster, a data store, and then decide which host access it at any point in time, all these zoning and fencing challenges that we try to kind of to address, right? We also allow us to have a very good integration with some key management operations like upgrades, maintenance mode, HA, over-provisioning your clusters to ensure that you have enough resources when something goes wrong. And as we know, things always go wrong, right? So that's why we make this choice. So this is very simple for the user. Here I have a screenshot of the page that we go and enable virtual SAN on a cluster. So it's a click or two, right? So first of all, the user can decide whether they want to bother with these groups or not. Justin, I know you had a concern about that. The users do not have to know anything about the fact that there are these groups. This is an architectural component. If they wish, they can know and they can think more the details. But what they can say is, you know what, go and claim automatically the devices. So you add their SSDs for your caching tier. You add either magnetic disk or low-end SSDs for your capacity tier. We go claim, we create internally the disk groups, and off you go. If you are more sophisticated and you want to do more things, you can do this manually. The same thing, you can go to now, we have the new features, and enable some of the features at the cluster level. Deduplication and compression, for example. Or very easily, you can decide what kind of cluster you want to have. A regular cluster, do you want like stretch cluster, or do you want to really deal with fault domains, the rack awareness feature we were talking about, I think, last year. So all these things are very straightforward. Now let's talk a little bit what is, in my opinion, the fundamental architectural principle of the product. Virtual SAN, unlike VMFS or other products in the industry, is not a cluster file system. It does not have a single namespace. It does not deal with metadata that are coordinated across all the hosts in the cluster. It is an object-based storage system. Every virtual machine consists of a number of objects. One VMDK is an object, for example. Then we have, for each VM, another object within which we create a small VMFS, cluster VMFS, where we store all the small files, the logic files, this kind of the metadata of the virtual machine. So you see a VM consists of a number of objects. And now each of those objects is distributed independently in the cluster. All the distributed algorithms are performed at the granularity of a single object. There is no coordination beyond a single object, right? So as your cluster grows, as the number of your objects grow, the system scales. There are no contention as all those scalability parameters are changing, right? This also gives us, it's not just scalability, it also gives us the ability to tailor the specifications of every single of those objects, every VMDK, every VM, according to exactly what the user needs, what the application requirements are based on policies. Which brings me to the next slide, if I can move this.
Go.
Can you?
Yeah, I got it. Go.
Okay, thanks. So every time, before we ever use virtual SAN, and for that matter, virtual volumes, the management model is the same here, the user needs to specify a policy or a bunch of policies. The policy consists of a number of rules that specify certain aspects of the requirements the user has for that specific virtual storage entity, the VMDK, the VM. For example, the fault tolerance level for that object, whether they want to have stripes for better performance, especially in hybrid configurations. Now we even have more features, like you choose between replication or erasure coding, depending on whether you aim for performance or capacity efficiency, or put IOPS limits, things like that. All those properties are specified by means of a policy's rules. And we even have what-if APIs that give to the user an idea of what those policies mean in terms of resource consumption, physical resource consumption in the system. The UI has actually a very, very basic version of those what-if APIs. if you really use the APIs through, through your tools, you have a much more rich semantics. So a virtual machine or individual VMDK, each of them have their own policy. So you have your database tables or your logs have one policy. The volume, which is scratch space, it doesn't necessarily need all those high fault tolerance and performance policies, right? You pay for just what you need. So during the life cycle of the VM, these policies are always tracked. We know what vSAN is doing in terms of enforcing that policy, and if there are violations because there is some failure or there is some change by the user, we adapt the underlying configuration of every VM, and we report to the user when this is fixed, or if there are not enough resources in the system to be fixed, we also report that.